Hey everybody, Nick Espinoza, your chief security fanatic here. And in drug news, we are talking about drugs in space. Now, here's what's going on. This is coming from the BBC, and it's super interesting to me. But on basically February 21st, a meteor-wide space capsule landed in the Utah desert after 8 months in orbit. Now, its cargo was ritonavir. Now, this is an antiviral drug that is used in the treatment of HIV and also COVID-19 as well. Now, it was carried out by Californian startup Varda Space Industries, and the mission aimed to demonstrate the potential for the automated manufacturing of pharmaceutical drugs in space, possibly paving the way for new and more efficient methods to develop medicines and vaccines. Now, Varda's W1 mission launched aboard a SpaceX Falcon 9 rocket in June of 2023. The capsule itself weighed around basically 90 kilos or 180 pounds or so, and theoretically was capable of manufacturing nearly 100 kilograms or about 200 pounds or so of products over the several months that it spent in orbit. For this initial mission, though, just a small amount of ritonavir was manufactured in that 27-hour test run. In-flight analysis indicated that the manufacturing process ran as planned, and while the final results are not yet available, Varda is currently busy preparing for a second mission to carry their first commercial payload. But why go to all this trouble? Right? I mean, we manufacture pharmaceuticals, drugs here on Earth. But over the past few decades, experiments aboard the International Space Station and other spacecraft have proven that it's possible to make small quantities of pharmaceutical drugs in space, meaning eventually we can make larger quantities. And it also turns out that microgravity conditions cause many of the processes used to build complex crystalline molecules, such as proteins and antibodies, used in many of the medicines to treat everything from cancer to heart disease, behave differently from how they do on Earth, therefore giving the production side of this a possible advantage. And so we're going to see where this goes, but as we move towards space, whether it's commercial space flight, government space flight like NASA and all of that, these are the advancements we're going to start to see. I mean, for God's sakes, Tang came from space as well, developed obviously for the astronaut on the Apollo's mission. So this is, I think, a very exciting thing. If we are able to get full-on production over there, not to mention, not having to basically have new construction here, any kind of waste or exhaust from this, meaning anything that could potentially harm the environment, obviously is going into the vacuum of space as opposed to into the atmosphere. So I think there's a lot of wins here if this comes to fruition, and we'll see if it does. But we are basically at the dawn, I think, of a new space era where we're going to be able to utilize space more and more for things like manufacturing, in this case, pharmaceuticals. So there you go. Think it's a good thing. Love to hear your thoughts. And please like, share, follow me here on Facebook and Twitter at NickAESP. And please feel free to subscribe to me at YouTube as well. And as always, stay safe, stay online, and please attempt to stay private. Thanks, everybody.